everybody. So this is going to be our notes on section 4.9, which is about El Nino and La Nina events. So the learning objective for today is that you can describe the environmental changes and effects that result from El Nino or La Nina events. You're going to gain knowledge about what El Nino and La Nina events are, what are going to be the things that cause them, and what are going to be some of the effects when we have these events. So we're first going to start out with going over some basics about the ocean currents on our ocean surfaces. And this is going to relate to what we learned about wind patterns a few notes ago, so you might want to revisit those if some of this is not making sense. So we are going to have these areas called gyres, which are going to be large ocean circulating patterns due to global winds. Now we are going to see in the northern hemisphere that these gyres are going to cycle in a clockwise motion, as we're seeing here and here. And in the southern hemisphere, they're going to move in a counterclockwise motion, like we're seeing right here and right here. And this is due to the direction of the winds. So remember that from the equator to 30-degree latitude markers, we are going to get what's known as the trade winds, where we are going to be moving from east to west, and we are going to have the currents being pushed east to west with these winds. Now up here between the 30 to 60 degree latitude, we are going to have what's known as the westerlies, which are when the winds are moving from west to east, and this is also going to be pulling water or ocean circulation in that direction, so it's going to be moving those currents from west to east. Now, all of this is going to end up resulting in some of these gyres and rotations, and ultimately it's going to lead to what's known as upwelling zones. And if you look on our diagram here, these are going to be the areas with kind of the dark blue areas. There are 5 of them that I'm showing here. And these are going to be areas of ocean where the winds blow warm surface waters away from a landmass, which is going to draw up colder, deeper water to replace it. Now, this is going to be really beneficial because cold water holds on to oxygen better than warm water. So when you are pulling up this cold water, it's actually going to bring oxygen with it. It's also going to bring nutrients. If you think of all the sediment on the ocean floor, that has a bunch of nutrients in it. And so when we are getting this water movement, it's going to be sucking up this cold water. It's going to be bringing oxygen and nutrients with it to the surface, which is going to be very beneficial for fishing because fish are going to flock to these areas because there's oxygen, there's nutrients for them. And so these are going to be areas in upwelling where we are going to get really productive fishing. And a lot of people are going to be making their livelihood based off of fishing in these areas. Now, one more thing that I want to point out is I want you to really pay attention to this area right here in the Pacific, where we are having the winds moving from east to west, kind of along the equator to 30-degree latitude south. And I want you to pay attention to this because this is the area that we're really going to be focusing on when we're learning about El Nino and La Nina events. So as we're looking at the grand scheme of the world, just in the back of your mind, have this area as something that you are paying attention to because this is what we're going to highlight, this spot. Now, because of all this ocean circulation, we're going to get what's known as the Thermohaline Circulation. And this is essentially this circulation that connects all of the world's oceans, which is ultimately good because it's going to be mixing salt, nutrients, and temperature throughout the entire globe. And this is going to be ultimately moved based on the currents that are being pulled by the wind, and it's going to result in differences in warm and cool temperatures, which is going to continue cycling. So some of the things that we see here, if you look right about here at number 1, this is where we're going to see warm water from the Gulf of Mexico moving towards the North Pole. So up here, like through past Europe. And once we are moving up here, you are going to be getting to colder areas up in the poles. And remember that cool is going to lead to condensing. So we're going to get cooler water. It's going to condense. it's going to become more dense and it's going to sink. These areas are also going to be saltier because the cold water is going to be holding on to salt better. Now, this cold water is going to go and spread along the ocean floor. So think about like the deep areas, that's where the cold is going to be coming in and moving down through. And it's going to be moving down south here based on the currents that are existing. And eventually, after we get this cycling, we're going to get areas where it's going to start warming up, especially when we get near the equator here because it's warmer. And when it starts getting these warm currents on top, those are going to get pulled. And remember, that's going to suck up the cold water to replace this moving warm water. So you're going to have the shallow warm currents moving in the direction that you see the red, which is going to pull up the cold that normally would have been down at the bottom of the ocean. And this is ultimately going to lead to global circulation of salt and nutrients and different temperatures of the water all throughout the entire globe. So this circulation is going to be important for keeping things dispersed throughout all of Earth. So now we're going to look at what's known as El Nino Southern Oscillation, which can be called ENSO for short. And this is going to be a pattern of shifting atmospheric pressure and ocean currents in the Pacific Ocean between South America and the Australia/Southeast Asia region. That area that I showed you on the map with the big yellow circle that I said to pay attention to, this is it. So we're going to see that there's oscillating or regular shifts from El Nino to La Nina conditions along the coast of South America. El Nino conditions are going to be warmer and rainier, and La Nina is going to be cooler and drier. And as you can see from this diagram, like I said, it oscillates, which is why we call it the Southern Oscillation. Because every few years, we're going to see shifts. So on this diagram, you can see that the blue is where we have La Nina events. Red is going to be where we have El Nino, and gray is going to be kind of these neutral in between. Now, we call them events, but as you can see from this diagram, it actually takes a few years for these to happen. So usually, like if we call it a La Nina event year, that just means it's hit like the maximum like climax of that event, not that it was the only time where we saw this starting to happen. So it kind of takes like a few years to build up and a few years to come down. But ultimately, when we call it like the event year, that's going to be where we're hitting like the maximum point there. So now I'm going to explain a normal year versus an El Nino versus a La Nina. So in a normal year, which we have on the left-hand side here, we're going to have the trade winds blowing the equator water from east to west. And what this is going to do is we are going to have the warm currents moving this way, and it's going to be warmer over in the Australia, Southeast Asia region. Now remember that when it's warmer, what this does is it leads to air moving up because heat rises. It's going to keep going until it hits that dew point where it's going to drop all of its water, which leads to lots of precipitation. And then it's going to continue cycling, and it's going to come down over here by South America, which is going to lead to a high pressure area because it's coming down, so there's lots of pressure. And this is going to be drier because it lost all of its air or water vapor over here. So what we're going to see in these normal years is we're going to have warmth and precipitation over in Australia, and we're going to have cooler upwelling off of the coast of South America because this warm water is moving. It's going to suck up the cold water to replace it. And these are going to be years where we have really good fishery conditions because we've got that cool water coming up with the oxygen and the nutrients. Then we have an El Nino year. And this is going to be where the trade winds get really, really weak. And because they are so weak, we actually end up getting almost like the reverse of west to east for these currents. And what's going to happen here is, as you can see, we are going to have the low pressure areas actually over near the Americas. Now remember, low pressure, you're going to have warmth, air is going to rise, it's going to rain a lot, you're going to have cycling, which leads to this cycling coming down over by Australia and Southeast Asia. So it's going to be a high pressure area in the West Pacific, and it's going to be cooler, drier conditions, less rain over here. What it's going to lead to, though, is the fact that we are not going to be getting a bunch of that movement of the surface warm currents, so it's not going to be pulling up the upwelling of cold water. So if you look at these diagrams here on the left-hand side, this bottom rectangle, this shows you what the upwelling normally looks like. Here in an El Nino year, there isn't any upwelling. It's just kind of suppressed, which is a bummer for fisheries. The fish are not going to thrive. They do not have as much oxygen or nutrients, which is going to lead to fisheries, those who come and fish for them, having a tougher time during El Nino events. So then we're going to have La Nina. And these are going to be times where the trade winds are way stronger than normal, which is going to be kind of an extreme version of a normal year. So we are going to get really strong trade winds, which means the currents are going to be pulled pretty intensely over towards Australia and Southeast Asia. This is going to lead to much warmer and rainier conditions over in the Australia and Southeast Asia region. And it's going to lead to way more upwelling over in South America, which is really good for the fisheries, but maybe not so good for lots of rain coming down on areas where flooding can be a concern. So this is going to be basically how the wind and the currents are driving some of the weather patterns that we are seeing based on these normal events or normal years versus El Nino or La Nina events. So now I'm going to get into talking about some of the effects that occurs because of this. Now there's going to be things that would be seen as positive and negative. So the effects that we're going to have of an El Nino event. Now, as I said, because of the suppressed upwelling, we're going to have less productive fisheries in South America. But what we are going to get is warmer winters in much of North America. So if you think of maybe years where we did not get any snow, it was warmer, it was kind of rainier, that probably was an El Nino year. It's going to lead to increased rain, but also increased flooding in the Americas, especially the west coast of North and South America. It's also going to lead to droughts in Southeast Asia and Australia. And this is going to lead to decreased hurricane activity in the Atlantic Ocean and weakened monsoon activity in India and Southeast Asia. And monsoon is where we get so much rain that it's like flooding. So it's pretty intense and not always so great. So that's what we're going to see in an El Nino. Then we're going to go to a La Nina, where we are going to get stronger upwelling and much better fisheries in South America than normal. However, it's also going to lead to worse tornado activity in the United States and hurricane activity in the Atlantic Ocean, which is not so good. It's also going to lead to cooler, drier weather in the Americas and rainier, warmer, increased monsoons in Southeast Asia. So all because of these trade winds, which impacts the currents, which impacts the upwelling, which impacts all of the weather, we can actually make a lot of predictions about when we're going to have more extreme years of like hurricanes and tornadoes and droughts, just based on tracking the cycling of when we're in an El Nino versus a La Nina event, because it has such widespread impacts and it's important to understand how all of these are connected and the effects that are going to come from it. So for your practice FRQ 4.9, we're going to practice the suggested skill of describing environmental problems. So what I want you to do is to describe 2 environmental problems that are related to the conditions of an El Nino event. So that will be your practice FRQ for 4.9, and those were your notes on 4.9 about El Nino and La Nina events.